Hey, this is Rick, and this is the first of many TypeScript game development tutorials. As I said, my name's Rick. I'm a longtime web game developer. I've done a lot with Flash and some with JavaScript, but recently I've really been impressed by TypeScript. So I'm a longtime object-oriented game developer, for the web, and object-oriented programming's been my thing for a long time. So having to switch to JavaScript was really painful for me. I know there are objects in JavaScript, but they're not class based and they're very different if you're coming from a truly object oriented language like, say, Java or C Sharp or Flash ActionScript 3. ActionScript 3 was actually a pretty good. Flash gets a lot of hate, and I understand that because there were a lot of bugs in the plugins that created a lot of security problems. But actually, as a game development tool, it was pretty solid. The problem is, of course, that it doesn't work in the modern era where we're going plug-in free, and we need something like JavaScript. And I was banging my head against the wall for months with JavaScript, trying to get more complicated games developed because it's not really. JavaScript is a language that has evolved over time, and it started out as basically something to add a little bling to your website, and it was great for that. But as it grew, it didn't really scale. I think the way most languages do. It's kind of more of a fun scripting language, and I know it can do a lot more now. And I know with Node and with a lot of add-ons you can do a lot more with it. But if you're used to nice class-based object-oriented programming, and a lot of game development, it's much easier to work with that. Then JavaScript's not really the language for you. Now, the nice thing about TypeScript is, well, there are several nice things. One nice thing is it is truly a class-based object-oriented programming language. It can be a little goofy at times, but a lot of that is because of its other big advantage, which is it compiles directly into JavaScript. A lot of people say it transpiles because JavaScript is, a similar. I don't even know the transpiles thing. I don't like calling it that. So anyway, when you compile TypeScript, it turns into JavaScript, and that is great because then you get all the advantages of JavaScript. You also have access to all of the JavaScript libraries that you might want to use when you're using TypeScript, and you have to create a definition file for that, or there's a website called definitelytyped.org that you can go to, and they have created just about any definition file you can imagine. If it's not there, it's not that hard to create a definition file. So odds are it's there. If not, it's certainly not that big a deal to create one. I've had to do that myself. But anyway, the other great thing about TypeScript is Microsoft, in its Visual Studio community, which is totally free, they've given you the ability to compile it and this great tool for developing TypeScript. So you don't have to go buy WebStorm or anything like that. So totally free, and it is a fantastic language. It is all object based. I mean, it has some quirks that you have to figure out how to work around. Um, but for the most part, it is just so much easier to work with than JavaScript if object oriented programming is your thing. So, what I'm going to do is I'm going to walk through doing what it takes to work with the canvas. We're going to start off with 2D, and we're going to do some canvas tutorials this time, some real basic stuff for working with TypeScript. So let me start out with a new project. This is Visual Studio Community 2015. By the way, you can download it for free. Just Google or Bing it. It'll come right up. And then just pick HTML application with TypeScript and say OK. And it's going to create a little HTML app for you. So this here greeter is a class, and if you open up index.html, here's this little web page. So if you want to run this guy, all you have to do is come up here, and click the play button, Taking a little longer than it normally does for some reason. Okay, making me look like a fool here. All right, don't take so long. Just go. And then it pops up over here. Okay, so now we have this just TypeScript HTML app. It's real simple. You know, this isn't a significant app here. So let me stop this. You know, all it does is basically like a hello world type thing, you know, but it, you know, shows you some of the basics. So you've got a class that looks a lot similar. It looks very similar to something you'd see in like Java or, you know, C# or something like that. So, you know, here's their class greeter, and on Windows on load, it just creates that and then grabs the content element, and the greeter thing stuffs some HTML into that, and it's not a big deal. Let me let's give it something a little different. So something that's a little more game-like. So I'm going to just get rid of this. You know, and the first thing I'm going to do is bring in a canvas and a context. So if, you know, you're already familiar with working with the canvas, you should be familiar with these guys. So, you know, in TypeScript, you actually have to declare types. So that's why we have this HTML canvas element here and canvas rendering context 2D. And that instead of just having like a straight up var that has no type associated with it. And this is really nice because it forces you to use the right typing, and you won't just get kind of muddled up different objects, you know, passing the wrong thing in, you know, when you're not supposed to, or looking at, you know, the signature of some function, you know, that you've done before and saying, what the hell did I pass into that? You know, what was I thinking there? So this should make it, for me anyway, having typing makes things a world easier to remember what I've done, to look at other people's code. It's just so much easier. So, you know, we're not using classes yet, but we'll just, I'm going to put in some game loop type stuff. So the first thing I'm going to do is drop in a game loop. So function game loop. All right. And now we need some sort of, you know, Windows on load that's going to fire that guy up. So let me grab this. Put you over here. All right. So this is just typical JavaScript stuff that is going to go on Windows load, and it's going to grab your canvas element and then get the context from that. That's the first thing you need to do, you know, when you're working with the canvas is, you know, got to grab the element from your HTML and then grab the context. So that means I need to actually have a canvas element inside of here. So let me get rid of, you know, the stuff that they've already got in here. I don't need that. I need a canvas element. So, you know, I made this 720p. And then back here, I grabbed that canvas element, and then I took the context out of it. You know, and the context is basically, when you're working with the canvas, the stuff you need to put there, you know. And basically, it's the context is what you write to do all your drawing and things, you know, like that. So then, of course, the last thing I need to do is call my game loop. So now I've called my game loop, and my game loop does nothing. So if you've ever done game development before, unless it's in Unity, most game development is done with a game loop where you manage all your objects and basically you draw everything and you do your physics, and everything like that happens in your game loop once a frame. Unity uses a game loop if you've ever used Unity, but it's kind of behind the scenes, and each object sort of manages itself from your perspective as a developer, but I guess that's beside the point. I'm kind of going on now. So let me put in there the thing that's really going to make the game loop work from a JavaScript or a TypeScript perspective. And that is this request animation frame. So the request animation frame basically calls this game loop every time a frame needs to be drawn. So everything you need to do is going to be done in there. So the first thing we're going to do is we're just going to fill up this space with something black. Now, if you don't want to fill it with a color, if you want it to be like transparent, you can use clear rect. But basically, if you don't fill your screen, the first thing you do, you're going to end up getting the same thing drawn like multiple times. So if you draw a circle and you have it animating across the screen and you don't just wipe the screen out at the beginning, of your game loop, then each time it's just going to draw over top of the last one. You'll end up having, that circle drawn every frame all the way to the end, and there'll be kind of like a streaking effect. So what you need to do first is just clear your screen. So that's what I'm doing here. I'm setting the fill style to black, and then I'm going to fill the rectangle, which is the size of my canvas, 0 to 1280 by 720 with black. So let me make sure I'm saved, and then I'm going to run that guy, and basically we have a black rectangle. So yippee. Anyway, we should do more than that. So the next thing we're going to do is we're going to try and draw something. So let me see. Why don't we draw a circle? So I'm going to cut and paste some code that I've got from another project, and then we'll step through it. So let's put this at x value 400, y value 400, give it a radius of 100, and let's see, the color, why don't we give this a color of red, and align with a 5. All right, so what we're doing here is, the first thing we're doing is saving the context. For this, we don't really need to do that. I could pull out that save, but we'll just leave it in there. I'll explain what that's doing later. The next thing we're doing is starting a path. Okay, so you have to do that before you draw any sort of shapes or paths. Then you set the stroke style to the color, which is red. And you could put in red or black or blue or whatever. And then I'm setting the line width to 5, and I am setting, and then I'm actually drawing the circle. And the first two parameters here, are going to be the x and the y coordinates. So the way it works on the canvas is x is how far you go to the right, and y is how far you go down, which I've always found confusing. That's the opposite of, any Cartesian coordinate system you do in school. But the reason I think it's that way is, the old scan lines on the CRT monitors used to scan from left to right, top to bottom, like. So I think that's why they put y as going down. It's just always been that way in computer graphics, and I'm pretty sure that's the reason. So then you tell it the radius, which will say 100. And this is actually not like draw a circle, this is draw an arc. So you want to draw the arc starting at, 0, and then going through position 2 pi. Like, so this is like in radians. Now, if you don't know the difference between degrees and radians, basically 2 pi is equal to 360 degrees. And the reason for that is if you're dealing with a unit circle, in order to get all the way around the unit circle, which has a radius of 1, you would have to walk a distance of 2 pi. So your distance in radians is basically how far you have to walk along the circumference of that unit circle to get all the way around. If that doesn't make sense, don't worry about it. It's not something you really have to deal with too much. But At least not yet. So anyway, this is just drawing a circle. And then we're making the stroke, and then we're restoring the context, which we don't need to know about yet. The save and restore, that's kind of for later. So if you left this out, if you're working along and you left the save and restore out, it wouldn't make a difference. So anyway, let's run this and see how this guy goes. And then we have a nice circle. Hey, yay, circle. Fantastic. Okay, so I have not yet shown you one of the main reasons that TypeScript is better. So you could put stuff like this in your game loop, but that gets really painful. So one of the cool things about TypeScript is you can create a class. So I've got all this stuff here, with the context and drawing, but really what I want to do is just tell it to draw a circle, right? So I've got this circle class. And I'll bring that guy over. So this is a class called circle, and it doesn't have to be, this detailed. Now, one of the things I don't have here is this eye shape. So I'm going to get rid of this part here because that's going to be late for later. I'll explain what it implements means and all that at a later time. So I've got this class circle, C circle. C is for class. But I could just get rid of the C and call it circle. So I've got this class circle, and some of the features of the circle are things like, where is it located on the x coordinate? Where is it or on the x axis? Where is it located on the y axis? What is its radius? How thick do I want the line to be when I'm drawing it around? And what color do I want it to be? And I could put things in later. I could put in things if I wanted to, like fill color, but I'm not doing that yet. So then we have what's called a constructor. This constructor is basically tells you how you create, the circle. So when you create a new circle, you have to give it features like x, y, x, where it's located on the x axis, where is it located on the y axis, what is its radius, what is its color. Now this color equals red, the reason it has this equal sign in the constructor is basically as a default. So if I don't feel like filling in the color, if I just want to just have it be the default, I could just leave it, not specify a color, and it will default to red. And likewise with line width, I have it default to 2. So if I don't tell it, what I want the line width to be, it's just going to be 2. I should probably make this consistent up here. The one thing about this is, having these defaults is I can never just let the color be the default red, but change the line width. I can't say, oh, well, I'd like the line width to be, 3 or 4, but I want to leave it red. If I do that, I also have to tell it, as I'm creating it, that it has to be red. But I'll show you that in a little bit. Hopefully that makes sense. If not, I'll cover it again. So anyway, all the constructor is doing is basically taking these values that I passed into it and setting the appropriate value up here. These are called public attributes. They're basically just variables like any other variable, but they're called attributes when they're on a class. So and then I did all that stuff related to drawing down here in a method called draw. So if I want to, I can create a circle, anywhere. Like, let's create a circle up here, and we'll just call this var my circle, and then circle. So this creates a variable of type circle called my circle, and then it equals a new circle. And that circle I am going to give a, let's give the circle an x coordinate of 50, a y coordinate of 75, a radius of 25, and we'll leave everything else default, and then let me create a var my circle 2, and then this circle will have at let's say 200, 500, give it a radius of 50. We'll make this one blue. Okay, so now down here in the game loop, instead of having all this junk to draw the circles, I could just go my circle dot draw and my circle 2 dot draw. Okay, and let's see what happens. Come on, baby. Uh-oh, did we get an error? C Shift J? Control Shift J? Hold on. Circle is not a constructor. Okay, so actually I think I have to create those below. So it doesn't know what circle is yet here, which is annoying. You know, in most object-oriented languages, you can declare things, you know, after. Let's see if this works. So it didn't know what circle was, even though circle was down here. And, you know, most object-oriented languages, it'll figure that out, you know, but for some reason TypeScript doesn't seem to do that. All right, there we go. So the problem was that I had my declaration of these variables before I had declared my class. And it didn't know what circle was, you know, which most object-oriented programming languages, that's not a problem. For some reason, it's a problem in TypeScript. It's always driving me crazy. So I've got, you know, my little red circle, I've got my big blue circle, and, you know, I could make a lot of circles that way, and it just, you know, it's an easier way if you're drawing lots of circles to, you know, do something like that. That way, you don't have to have all of this code every single time you want to make a circle. And, you know, if you're thinking, hey, what's the big deal? You know, you've only got 2 circles. Well, when you're writing a game, you know, these might be spaceships, and you might have like 50 of them running around. Or in, you know, a game like Asteroids, you have asteroids coming from all kinds of places. And you don't want to have every asteroid being, you know, drawn out linearly in your game loop, because that just gets to be ugly and untenable. You can't maintain that sort of thing. But if you have these things broken out so that, like, you know, if this were like an asteroid class, then, you know, you could manage each asteroid individually. So, you know, let's go add a few extra things. So now, if you want more than one shape, so circles are great, right? We all love circles. You know, who doesn't? But you don't usually just want something simple, like something just like a circle. You might want lots of stuff. So we're going to have what's called an interface, because the important thing here is that we can draw these guys. And, you know, so an interface is where you set up like a common thing to do with all of them. So we're defining shapes, and the common features of our shapes right now are going to be that you can draw them, they have an X and Y coordinate, they have a color, and they have a line width, you know, for drawing. So we're going to get rid of these my circles here. Let's delete that. And delete these my circles. Okay. And we have this eye shape. Now, if you remember, I had pulled out that implements eye shape out of my initial definition of a circle. So eye shape, it's called, I put the eye in front to basically indicate that it's an interface. And now I've got C in front of circled to let you know that this is a class. So it implements iShape, which basically just means that it has all the stuff that's in iShape. So later on, if you want something that lets you deal with iShapes, you'll know when you're grabbing them that it has a draw function and an x coordinate and a y coordinate, for instance. So I've got this array that I have set up here. Hopefully this will work. And this array is of iShapes. So, you know, I want more than just a circle. So let's drop in a rectangle, and then we'll walk through what the rectangle's doing. Okay. So now I'm dropping in a rectangle. And, you know, the rectangle shares a lot in common with the circle. It's got an x-coordinate, y-coordinate, line width, but it also has, you know, a width and a height instead of a radius. So those aren't values that you'd put into the iShape because they're not common to all of your shapes. And, you know, it has the color just like the other one. So then we have a slightly different constructor for our rectangle. We have, you know, a x value, y value, width, and height, which in the other one we only had a radius. So then we also have the color and the line width, which are defaulted there. So in our draw, we're doing all the same context stuff we were doing for the circle, but instead of drawing, you know, with the arcs right here, we're drawing a rect, you know, using the context to draw a rect. So if you notice, it's got all the same stuff. It's got the context save, it's got the begin path, it sets your stroke color, it sets your line width, but then it draws the rectangle instead of drawing your arcs to create a circle. Then it does the stroke like it did before, and then it restores. So, you know, now we've got something kind of similar, but we also have what I created before was this shape array up here. So I've got this array of shapes, and what I want to do, if you don't know what an array is basically like a list of objects, you know, and you can loop over them in order to, you can loop over your list of objects in order to do something to all of those objects. So now I'm going to take this array and I'm going to put in a for loop in my game loop to loop over all of those guys and draw them. And I know, because I'm using an interface, iShape, and everything in there is an iShape, I know that draw is a method that's available on all of them. So now I just need to go and create some rectangles and circles, you know, at the beginning of my game when it's all initialized. So let's just go down here to onload, and before the game loop is called, we want to actually create some objects to put in there. So, you know, here we're creating a circle. At 550, we're creating a rectangle, or at 500, 500, we're creating a rectangle at 200, 200. Let's create another circle at, like, you know, I don't know, 70, 500. We'll make that we'll give that a radius of 20. We will make it, here's another thing that's nice, is when you're using Visual Studio, it actually pops up and tells you what it's looking for the next parameter. Like it's telling me that the next thing I need is a color. So let's pass in pink. You know, we'll make this a pink circle, and we'll give it a line width of 4. You know, so that'll be a little bit different. And then with our rectangle, you know, let's make a rectangle that's at like 900 by 300, or 900, x coordinate 900, y coordinate 300. We'll make it 150 wide. We'll make it 30 high. And let's see what parameter comes next. If I put a comma here, it says it wants color next, so I'll put in purple. And I won't bother putting in a line width, we'll just leave the default. And then let's see what happens when I run this guy. All right, so it just, drew our various um, shapes all over the place. I mean, there's nothing much going on here. And, in fact, you wouldn't even need a game loop for this because we're not moving anything. But, if I wanted to move them, I could actually change their x coordinates now and just move them. So let's go back here. Well, let's just say I want to have them all just shift 1 pixel per frame off the screen. So in addition to drawing all of them, I could say shape.x equals shape.x plus 1. Now, if you're a regular developer, you probably would say, well, why aren't you doing shape.x plus plus? Plus, which would be the same thing. But just for clarity, for people who are newer, what we're doing is we're just taking the x value that's on the shape and we're adding 1 to it. So each time through, our shape, all of our shapes, every single one of them, because this is in the for loop, every single one of our shapes should be moving to the right. So let's run that and just see. Is that happening? Yep. So 1 pixel per frame to the right until they're gone, basically. So if you aren't familiar with for loops, I think I covered these. Basically, all a for loop is doing is saying, okay, we're going to start at 0. We're going to go until we get to the end of this shape array. And this I++ is basically, looping through all of these and getting every shape. So you have your shape array here, which I created and initialized with those shapes that you saw earlier. And I'm looping through each one of these in the array, grabbing it by its index number. And then drawing it and then adding 1 to the x value. I'm not sure, you see. So now that I'm doing this video, I'm kind of wondering, maybe I need to do this just for people who are more familiar with coding in general. Like, I'm not sure right now I'm not sure who I'm targeting, because I'm explaining like everything to you, but I'm probably doing it too fast. But anyway, I'm just going to move forward and hope that, if anybody watches it and then they, want something different, they'll tell me. So if you're not, if this is too fast, too slow, let me know. I'll change the way I'm doing my tutorials. Maybe I'm covering too much. Maybe I'm not covering enough. I don't really know. This is my first tutorial, so I'm going to keep doing them though, and I'm going to hope that, I get some feedback on these. But anyway, moving on, let's do some other kind of shape. Okay, so let's just come up with something else. Let's say that we want, a game like Asteroids, and we want to create, an asteroid. So we need an asteroid object, obviously. So, we've got our circle, we've got our rectangle. Let's just drop an asteroid in here. How are you going to draw an asteroid? Okay, well, the first thing we're going to need to draw our asteroid is points, like XY coordinates, because we're going to draw that guy, just based on some various XY coordinates. So I'm going to create a class called CPoint, or just point. And basically all this is going to have is, an XY coordinate, just XY values, and then my asteroid is going to be an I shape. It's going to have a draw. It's going to have an XY line width, that sort of thing. So this is a shape, like the other shapes we've been drawing. And we've got some defaults, and we've got, in the draw function, we're looping through a list of points, and I'll show you how those are set up in the constructor. So here's the constructor, and we have those points, and we have, when you create it, you're going to be giving it an X coordinate, a Y coordinate, a size, like how big do we want this thing, and then a color and line width, which is pretty typical. So, here we've set the X and Y coordinates, and then we've set the size. And now I'm just coming up with a list of points. And these are just points to draw to. And the way I came up with these points is just, I drew out a little asteroid on graph paper, and I just figured out where the X and Y coordinates are. But because I wanted to vary them, their location, like how big this thing is based on the size, I have to multiply all of these X and Y coordinates I came up with on graph paper by the value for size that I passed in. So you could, scale this thing up or down based on the size value. So then if I want to actually create one, I can just add one here. And I don't know if that's good. I guess that would be an okay position for it. Now, this size of 20 is actually a little deceptive because it's sizing it based on how big the default, how big those initial coordinates I have are. So you're really going to get something that's about 5 times as big as whatever value you pass in there. But so I create this new asteroid, and when I create this new asteroid, it's coming in here and it's putting it at its location and it's scaling up. It's basically multiplying these points that I had added, one at a time. And this is just another array. This point list here is just an array of points that are going to be drawn in my shape. So then now that I've added it, I should just be able to run it. And it's right there, and it's moving off the screen. So, we have this asteroid that's just kind of moving off the screen with everything else. So, let's see. Can we make this rotate? Let's have a little fun. See if we can make this rotate. So I will add to my asteroid a public rotation number equals 0. All right. And now this is going to be, the rotation is going to be in radians. So basically it's going to go from 0 to 2 pi. So from, 0 to 6.283, something like that, to tell you how far you've rotated the guy. So, because of that, if we're running at 60 frames a second, I can't be adding, say, 1 to it each time, because if I add 1, it's going to be flipping around really quickly. So I'm going to say this dot rotation plus equals. Plus equals means it's the same thing as saying rotation equals rotation plus whatever, 0.02 maybe. I'm just making that number up. I hadn't thought it through too much. I don't know if that'll spin extra fast or slow. And ctx dot rotate. Okay. This dot rotation. Now this is a time when you absolutely want to have the save and restore, because this rotate doesn't just rotate your object. It rotates the whole canvas, which is weird. So you want to basically make sure that after you've drawn your object that you've reset this rotation, and the way you do that is with the CTX save and restore. The other thing I want to point out is you can also create methods. Like if I wanted to create a function in here, you may be asking, what is this why is it draw equals, parentheses colon void with this fat arrow there? And the reason is because that's the only way in TypeScript to get this to work. TypeScript and JavaScript are really weird in that this doesn't mean what it does in a lot of languages. It does some strange stuff, and the way you get it to behave normally is to use this fat arrow. So if I had public draw void and then had that guy, and not the one below it, then if I said this dot rotation, it would probably come up with nothing. like this dot rotation plus equals 0.02, it would probably not know where the heck to get the rotation. It does some weird things. Sometimes it seems to end up grabbing it from like the main document, in your HTML. I don't really understand what the initial intent of this was in JavaScript. But in JavaScript, you would usually put in something like, in your constructor, something like this equals self, or self equals this, or, underscore this equals this. And the nice thing about TypeScript is it does all that for you, but you have to remember to use these fat arrows. And I have in my classes forgotten to use these fat arrows and really paid the price for it. So anyway, let's see if this actually works and rotates our object. Oh, see, I must have done the translation at the wrong time. If you noticed, like, look at it's rotating, but it's rotating way out there. So I didn't put my rotation in the right place. Always forgetting which order these guys go in. So it's, I think I have to do it after I draw, because I believe I have to draw this first, and then after I close the path, do the stroke, maybe then I rotate it. That doesn't seem to be doing anything. But yeah, you got to be careful when you rotate. I'll have to look at my code to see, when I've got some other code. I'm always forgetting where to put the rotate, because yeah, see, that's rotating it around this point here, and it's going to swing way out there. It's not rotating around its center axis. There's some translation. I know what I'm doing. I know why I have to do it. So what I should have done is drawn this guy without offsetting. Like here, when I'm drawing it, I'm offsetting everything by the X and Y values. Instead of doing that, what I actually need to do is get rid of this. So, and then translate the object before I rotate it. Translate basically means move the object to whatever. So I'm drawing, these various points, and I bet you this would work for the rectangle. So I'm drawing these points, and if I do this, it's basically going to draw it kind of up in the corner. So let's see if the asteroid's getting drawn up in the corner. Yeah, see there, and it's rotating. Notice it's rotating correctly, but it's getting drawn up in the corner, which is not what we want. We want that guy to be drawn, like based on its X and Y values. Because right now we're just ignoring the X and Y values and everything else is moving off the screen. So let's stop this. And so what we need to do is we need to translate this. And this is another one of those things I forget, is like, do I translate before or do I translate afterwards? Translate basically means to move something. Fancy words. So we want to move this guy to the this.x and the this.y. And I'm either going to have a similar problem to before or after, because I can never remember. I always have to go look it up, but I don't feel like looking it up right now. So let's see. Oh, yeah, so we're translating it after you rotate seems to result in it spinning around that point. So we're going to go this way and see what happens. Translation first, then rotation. Okay, so that's exactly what we need, is we need it just kind of like tumbling like that, because it's supposed to be an asteroid, So that is what we were looking for. And we could also add a nice ship in here, if we're making an asteroids game. Let me grab my spaceship code. Now this is going to have the same problem that the asteroid did, because when I was coding this up in my in my little pre-recording coding, I actually didn't think about doing any rotation. That just kind of, excuse me, kind of spur of the moment dawned on me as something I should just show you, and that's why I got burned. So always come prepared, kids. Um, but yeah, see here I'm doing the same thing. So I'm creating this constructor, except it's got a lot more or a lot less points because if you remember, um, the spaceship from Asteroids was kind of like a funky triangle, but I'm adding the this dot x into each point that I'm drawing instead of into the instead of drawing them just at the center and then translating it, which is what I should be doing. So, this is not the way you want to do it right there. With adding your X position here as you're actually drawing it out. I mean, you can as long as you're not, doing any sort of transforms. But so I've added the ship, and then I've actually, if I don't add it to my shape array, because if you remember, I'm using this shape array up in the, can I get up there? Up here in the game loop, I'm looping through everything that I have put into that shape array, and I'm drawing it, and drawing it with x plus 1. So let's go back down. And so I have to add something to the shape array. And if I haven't gone over this yet, I've created this array called shape array, which holds all the eye shapes. And I use push to push a new value into that shape array. So push is basically a function that just adds a new shape to that shape array, and then I'm going through and drawing each one. And this is kind of a more object-oriented way to do some of this stuff. So let me, otherwise I'd be like drawing all of these things separately, and that becomes a real pain to manage. So let's see, hopefully there's nothing that's going to be bumping this guy. And maybe I'll draw him at 200. So we'll just run this. Okay, so he's over there. He is bumping into that triangle, or that rectangle rather. So this is my little ship, that I would use. Let me make sure he's not. I'm going to push him down a little bit. He's too high up on the Y. So if I put him down by like, purple, messed up my purple. If I push it down to like maybe 450, give that a try. All right, so there is my little spaceship. There's my tumbling asteroid. We can go through and we could add input and, other things to the game to make it. I mean, this is not a game. This is just real basics of the canvas. But, what we could do next time is we can go through and make it a little bit more of a game. Now, the other thing to remember is you're not going to be drawing lines and stuff like that in games, except for kind of for debugging purposes. I mean, the only time I actually draw things like this with lines in a game is basically to debug it. For the most part, you use sprites and you use sprite sheets. Basically you draw images, stuff that you've drawn in Photoshop, and you put those into the game. You don't have to like do all this stuff with points, but all of that is going to be a later tutorial. We're first going to get a little bit more into just managing these objects and how you would approach this from an object-oriented perspective in TypeScript, because even if you're not looking to learn TypeScript because you want to develop games, let's say you just want to write business applications or even websites or anything, using the object-oriented approach works really well if you have very large programs and applications. If you're using JavaScript, the problem I was running into a bunch of problems using JavaScript. One of them was Like, let's say you mistype something and it doesn't know what type is. Let's say rather than push, here I actually, accidentally type, PFSH. If I go to try and like run this, look, it's telling me, hey, there is an error. You can't do that, because it knows that this is, not a function. I mean, actually, that's a little bit less of a problem with functions than it is with variables. So I was running into this all the time where I'd have, here, instead of typing in this dot size equals size, I'd type in this dot, SZZ equals size. And then, it's giving me the errors down here. If I run it in TypeScript, it gives me an error. It says you can't do that. You never told me that there's something called SZZ or SZE, to set it to. And later down here, the problem is if that you then use size, like this dot size at some other point, like up here somewhere, if I try to use this dot size, it never set it. It created a brand new variable called SZE and, tried to use that. And it gets really confusing, and you spend a lot of time stepping through your code saying, okay, well, why isn't this value what I expect it to be? And, that was just such a huge hassle. Having something that compiles, that tells you when you have an error, or don't, is huge to me. I mean, it's huge for writing applications. And, the other thing is the whole object-oriented nature of it. Creating objects in JavaScript is kind of a pain. Like their prototype method is kind of painful to work with. And it doesn't always do what you'd expect. And using the fat arrow to make sure you get the right, this is also just really so much better. So if you're coming from a language like ActionScript, if you were a Flash guy, or if your language was C# or Java, or even to some degree like C++, TypeScript is so much better than JavaScript. It does so much better. Like if you're looking to do object-oriented programming. But anyway, we'll be moving on to some other tutorials. I'll try and get some input here so that we can, actually have these guys moving around when you're hitting keys, or maybe mouse clicks, that sort of thing, with the next tutorial. All right, thank you so much for watching, and remember to subscribe.